Hello everybody, and welcome to the second part of this tutorial series for setting up Pixel Perfect in your Unity projects. In the first part, we discussed setting up the Pixel Perfect camera component. Now in this part, we are going to discuss setting up your user interface to be Pixel Perfect. Just as a reminder, if you'd like to follow along or view my project files for yourself, you can do so at github.com/alexgarbus/unitypixelperfect-tutorial. Now, because all the objects we've worked with so far are in Unity's world space, they are all affected by the Pixel Perfect camera. User interface elements are not. They do not, by default, fall within the set of objects that the Pixel Perfect camera affects the rendering for. So we actually need to set up our own systems for allowing UI elements to communicate with the Pixel Perfect camera. So I'm going to start by setting up a font here. So I've gone ahead and picked Press Start 2P, which is a pixel art font available on Google Fonts. When you're importing fonts for use with pixel art games, you want to check with whoever's distributing the font to see if there's like a specific size that it needs to be set to. In the case of Press Start 2P, it needs to be set to sizes that are multiples of 8 to fit with to be pixel perfect with the rest of the graphics. And I'll show it off a bit more once we get the text into the scene. So I'm going to be using Text Mesh Pro for generating the text. It's just a it generates cleaner text than Unity's default text generation system. And Text Mesh Pro, I believe, is I believe it comes pre-packaged with Unity. If you don't have it, you can just go to the package manager and Text Mesh Pro install. And we are going to go to Window, Text Mesh Pro, Font Asset Creator. Now, if this is your first time using Text Mesh Pro in the Unity project, you'll need to import TMP Essentials, so just let it do that. Alright, so that's been imported. So we've got our Font Asset Creator here. We can go ahead and close out of the importer. It already has the Press Start 2P font selected. This is just where you'd select your source font file. And then you're going to want to set the packing method to optimum. And you want the render mode to be raster hinted. This is just so it renders the font pretty crispy-like. Because if you have the other rendering mode selected, it'll smooth them out more, like give them smooth corners, which you don't really want for pixel art fonts, because you want them to be nice and crisp, have sharp-edged corners. The rest of these values you can play with to see what works for you in your font. Since we're not going to be using any like font effects like outlines or underlays, I'm just going to set the sampling point size to 16, which is the same size that we're importing the font with, and padding to 1. And then the Atlas resolution is just whatever is the smallest resolution that will fit all of your font characters on it. So we're going to generate font atlas. And as you can see, we have our atlas with all of our font characters here. We should be good to save. Go ahead and save in a folder of your choice. I'm going to choose just the fonts folder. And now the asset is generated, and you can of course go back and edit this if need be. So now that the Text Mesh Pro asset is generated, we're gonna go ahead and start setting up the UI. So there's two types of UI in Unity. There's world space and screen space. World space exists in the scene as it would a regular game object, where screen space is rendered directly to the screen. So we're going to start with a world space canvas. So we're just going to create create UI and canvas. And then for this canvas, you are going to set the render mode to world space. I always like to make sure that they are above all the other layers, so just set their order and layer to something higher than your other game objects. And then set both the dynamic and reference PPUs to 16, or whatever PPU you chose, which in my case is 16. I'll go ahead and go over to the scene view here, and that you can see that's way too big. We're gonna set this to position. This is going to be a little speech bubble that floats above floats above Pixel Pickle's head. So we can position it about here. This is about one tile above Pixel Pickle. And then the size is going to be 2 units wide and 1 unit tall. Let's move it up just a bit. So 1.5, or let's do 1.25. Oh wait, 1.25. Cool. So you can see by the outlines that it's going to snap with the pixels surrounding it. Next, we are going to add a image component. So UI image, and then select the UI sprite you've created. Set its PPU multiplier to 16. And we're going to set it to just stretch to fill the whole canvas. Alright, so as you can see, it is perfectly lined up with the pixels surrounding it. And I can also, since we set up the 9 slicing, I can resize it. And you can see it's not distorting at all. Just make sure that your image type is set to sliced for it to exhibit this behavior. And finally, we're going to add we'll add this to the image, UI, Text Mesh Pro, and set our vertex color to black or something that'll contrast against the white background. We're just gonna say hi, and go ahead and for the material or the font asset, select the font asset you generated. Real quick, I need to make sure that the text also resizes to fit the image containing it. So yep, we got ourselves a nice hi message here. And as you can see, we've got our font size set to 1. Essentially, when you're working in world space, think of the font size as being measured in units. So this is taking up 1 Unity unit. And the smallest size we can support is 8 pixels, which will be half of a Unity unit. So we can just set this to 0.5, and then we'll center it. And as you can see, all the pixels line up. If we go any lower, say 0.25, you'll see that they no longer line up. The middle of the H and the dot of the I here, for instance, are thinner than the pixels of the image bubble containing them. It's not going to hurt anything if you have inconsistent pixel sizes like this. It's just for pixel perfect rendering, one of the points of it is to make sure that all of your art appears snapped to a grid, and so having the UI snap to a grid as well helps enforce that. So what we're going to do now is, since this is a speech bubble that needs to follow the player, we're going to drag the canvas onto Pixel Pickle. Pixel Pickle. I still can't get over that name. And so now the canvas is we'll call this since we're gonna have two canvases, so I'll just call this world space canvas. And this is going to serve as a child of the player, so this will move with the player. So we'll hit play, and actually real quick, since we're on PC, let me switch this back to using my recommended fixed aspect ratio settings. So you'll notice that it stays above the player, but it doesn't snap to the pixel grid while the player does. And again, this is because the pixel perfect camera in its current state has no effect on the world space UI canvas. So we need to actually make a custom script that is going to communicate with the pixel perfect camera. So go ahead and make a new folder for scripts if you haven't done so already, and create C# script, and we're going to call this Pixel Snapper. Open it up. All right, so we have Pixel Snapper loaded. So what we're going to do is, you don't need either of the system namespaces. You do need the Unity Engine namespace, and you do need Unity Engine.u2d, which contains the script for the pixel perfect camera. Then you're going to need to store a reference to the pixel perfect camera. So private pixel perfect camera, pixel perfect camera, and then the start method. You can, if you like, you can plug this up manually via the inspector, but since we know that the main camera in the scene is going to have a pixel perfect camera component attached, we can just do pixel perfect camera, set it equal to, camera.main.getComponent pixel perfect camera. So the rest of the code here is going to be done in not the update method, but the, I'll just get rid of these comments for now. But the late update method, which is called after all the update methods and all the mono behaviors in the scene have completed. And so this is because we want to change the position of the UI element after any other position changes have been performed. So all the code within late update here is going to be contained within an if statement. We're going to check if transform has changed. This is a true-false value that tells you whether the transform, the position, rotation, scale have been updated. And at the end, we're going to have transform that has changed equals false. Now this will be done after the rest of our code is run, just to tell it that this doesn't count as the transform being changed, because we are going to manipulate the transform within the late update method. So we're gonna go ahead and get vector2. We're gonna have a target position. And we want this to work for both objects that are attached to other objects and objects that are kind of existing on their own. So we're going to have a check for whether this object has a parent. If it does have a parent, then the target position is going to be equal to the parent position plus, we're going to cast this as a vector2 because we're going to get the local position, which is of course the position in local space, the position relative to the parent object. Oh, this also needs to be casted as a vector2. Now, one more thing we need to do here is we need this local position to be rounded to a it needs to be snapped to the pixel grid. And so this is why we have the reference to the pixel perfect camera, because it actually lets you generate a position that is snapped to the grid with a method called round to pixel. So you simply call pixel perfect camera dot round to pixel and give it the position you want to round to a position on the pixel grid, and then it'll calculate a position that is snapped to the pixel grid. Now, if there isn't a parent, if this object is not attached to a parent, then we are going to simply set target position equal to transform.position. And then finally, before setting transform that has changed to false, we need to do one more. This is where we're actually going to set the new transform position. So we're gonna call around the pixel again, this time using the target position. So this will take what we have stored in the target position, round it to a position that is snapped to the pixel grid, and set the object's position to that position. And so that's all the code we need to write for the pixel snapper. So I'll go ahead and attach it to the world space canvas. And then once I hit play, it is now snapping to the grid while also still following the player. And because of the way we wrote the code, you can also, if you want to say like have this hovering up and down or something like that, you can still adjust the relative position, and then it'll still snap to the grid while also maintaining its relative position. That high is very high up in the air, if I do say so myself. Haha, funny. So that covers it for the world space canvas, but there's another type of canvas we now need to cover, screen space canvases, which are, as I mentioned before, rendered directly to the screen. Essentially, think of like a heads-up display, like if you have buttons that need to be on the screen at all times, regardless of where the camera is, these would go in screen space. So we're going to go ahead and create another canvas. Canvas. Screen space canvas. So we're going to go ahead and keep it at screen space overlay. And then you see it has this pixel perfect option here. We're going to go ahead and select it. Now this doesn't really affect the, this doesn't really like snap the pixels to a grid or anything. This is more so just how it renders individual images. Like when you have this checked, it should render them like crisp and without any of the blurring we saw earlier. But this doesn't really have much of an effect on the actual position of the UI elements. For UI scale mode, for now we are going to set it to scale with screen size. This is typically what you want to use with fixed aspect ratio games. So we're going to set this reference resolution to what we set before. Let me make sure I reset. Okay, that's reset from when I was demonstrating how to make it work with mobile devices. Reference pixels per unit is, of course, 16, or whichever value you selected. Then let's just create two buttons on the left and right sides. So we're going to go UI, image, . Now, because this is screen space, you actually can just leave the pixels per unit multiplier at 1. You'll see it's lined up. Well, not lined up, but you'll see that the pixels are the right size. Then let's go ahead and set it to, let's say 16 by 16. And snap it to the bottom left corner of the screen. I always like to have a bit of padding. So let's say plus 16, plus 16. And then let's, like we did before, give it a text mesh pro element to contain. We'll call this, or not call it, sorry, we'll set it to the pixel font. We'll just label it P for pickle, or pixel, whichever you prefer. Set the vertex color to something we can see. Set it to fit the size of its containing element. And then this is actually, now the font size is actually in pixels, not world space units. So we want to set this to 8 and position it in the center. Oh, yeah, I need to, my bad. That's for the UI element, and then for the actual text, there we go. Now we're just gonna duplicate this, but then this one, but the second one will be on the right side of the screen, and minus 24, or minus 16, sorry. Minus 16 plus 16. There, so now we got two P buttons, the pixel button and the pickle button, or the pickle button and the pixel button, I don't know. They're not actually buttons either, they're just images with text that stick to the edges of the screen. Now, like I said, because this is because right now we're assuming the game is going to have a fixed aspect ratio, you are good to leave the canvas scale mode at scale with screen size. As you can see here, it just, as it says, it scales with the screen size. The position doesn't change at all because there's no need to. While the screen size may change, the aspect ratio never does. So it's just nice and sticks there. And then you'll see that because we're using the pixel perfect camera and these are just stuck to the screen like that, they are pixel perfect. They snap with the elements around them. However, let's say you're working with a game that needs to be made for variable aspect ratios, like say a mobile game. You'll see that is no longer pixel perfect. Or wait, hang on. Of course it isn't, because I'm not previewing the camera in edit mode. And let's swap these two values. We'll just assume this is a game being made for portrait oriented devices. So of course the reference resolution here will need to match the reference resolution you set on the pixel perfect camera. But as you can see, it's not really pixel perfect. These were originally the same size as the world space bubble, but now they're not. And you can adjust this value to determine whether they're influenced by the width or the height. But even then, because not all mobile devices share the same aspect ratio, there will still be differences across different devices. They won't be the exact same size. Like here, let me actually bring one of these to the center. And drag it up a bit. And of course, it's a bit distorted because I'm zooming in. But as you can see here, well, these are both set to be the same size, but the screen space element appears slightly larger than the world space one. And it's just gonna be a different size on different devices regardless of what you have set here. So if you can't scale with the screen size, what do you do to ensure that the screen space UI elements appear pixel perfect on all devices? Well, there's another scale mode, constant pixel size, which of course lets you set the reference pixels per unit, and a scale factor. If we go over to the main camera, you'll see that it gives us a pixel ratio, and this is the value that you want the screen space canvas to have as a scale factor. So as you can see, they're all lined up now. But then if we switch devices, let's go to iPad. Oh no, it looks the same. Let's try Galaxy S7. You'll see that the this value, the pixel ratio, changes to 8, and so you'll have to change the scale factor to 8. But of course, this is just in the Unity inspector. This needs to be set at runtime, and so we're gonna write another script that again communicates with the pixel perfect camera to set the canvas scaler scale factor at runtime. So we're going to create another new C# script, call it pixel perfect canvas scaler. Open it up. All right, now that we have pixel perfect canvas scaler opened up, we don't need system.collections.generic, but we do need system.collections. And then we're also going to need Unity engine.event systems, Unity engine.u2d. Again, this contains the pixel perfect camera, and then Unity engine.ui. We also want to ensure that any object that this script is attached to also has a canvas scaler. So we're going to use require component type of canvas scaler. Next up, we need to, instead of inheriting from mono behavior, we're going to inherit from a special class contained within event systems called a UI behavior. Reason being is this gives us access to the onRect transform dimensions change method. This is called anytime the canvas dimensions are changed. It's a lot better than just calling it every frame and update. And we actually will not need update because we are only going to be using onRect transform dimensions change. We also need to, again, gotta remove the default comment there for now. We also need to make sure that start is defined as an override void. So we're going to have two references to two components. We're going to reference the canvas scaler, and we are going to reference the pixel perfect camera. We know that this object is going to have a canvas scaler attached to it, so we can simply say canvas scaler equals get component canvas scaler. And then, as before, pixel perfect camera is equal to camera.main.get component pixel perfect camera. So now we're going to go ahead and define a set scale factor method. And this is just going to be one line, being canvas scaler dot scale factor is equal to pixel perfect camera dot pixel ratio. Now, the thing is, when on-rec transform dimensions change is called, the pixel perfect camera's pixel ratio won't actually be updated until the end of the frame that on-rec transform dimensions change is called. So what we need to do is wait for the end of the frame before calling set scale factor. So we're going to accomplish this through a coroutine, which of course is a method that can have its execution paused. We're going to call it set scale factor at end of frame. And the first line will return a new wait for end of frame. This, of course, will wait until the end of the frame, as the name implies, and then we can call set scale factor. Then in onRec transform dimensions change, we can simply just start coroutine set scale factor at end of frame. Now the thing is, this method onRec transform dimensions change will also be called when the object is being disabled. And of course, you cannot start a coroutine on disabled objects. So we need to have a check here. Just make sure that the game object is indeed active in the hierarchy. Because if it's not, it will generate. If it's not and you try to start a coroutine, it will generate an error. And that is it for the pixel perfect canvas scaler. Now just save. Attach it to your screen space canvas. And then we'll hit play. Now you see it's they're all lined up properly. And then if we switch the device to say, let's go back to iPad. It automatically sets a scale factor according to the pixel perfect camera's pixel ratio. You can see it's 6 here, and then if we switch to S7, it goes to 8. And it also works when you change the orientation. Very cool. And that's it. You've now set up Unity to not only be pixel perfect, but adapt to different screen sizes and maintain its pixel perfect look. I'm not good with goodbyes, but thanks for watching!